We are going to pass this over to Dr. Cesare Wright with Kino Eye Center. He has just a wealth of knowledge in a number of topics. So we've worked with the Kino Eye Center, and he can explain the name of Kino Eye Center. It's very interesting for several years here, particularly around programs related to artificial intelligence and autonomous vehicle design and construction, and a number of the programs that we have driven really across Texas and across the U.S. So with that being said, I think we should have Cesare. So Cesare, you have the stage. Thank you.
All right. Thank you for having me. I'm going to go into a few different things. One, very quickly, so something Ramel brought up. People are always confused by the name of the nonprofit that I work with, the Kino Eye Center. It actually there's a man named Dziga Vertov that was a Russian film theorist. And you may wonder what that has to do with STEM. He was a pioneer in the idea that technology not only reflected society and culture, but also reinvented culture and society and the way we live. So he had the idea of the Kino eye, which is the camera eye, and the idea that the camera didn't just capture a human reality, but it actually recreated new realities that only a machine could see, which I think is very interesting. And the basis of all of my research and the kind of things I work on are really around that intersection of technology and culture, and the belief that as an engineer, your job is to make somebody's life better, happier, safer, or more fulfilling. And if you fail to do that, then it doesn't matter how cool and techy the things you do are, you failed in your mandate as an engineer. So that's a little background. I work with Microsoft, created a number of programs, Microsoft Epic, which focuses on K-12 education around artificial intelligence, drone technology, esports and gaming, and augmented and virtual reality. So any of you interested in those kind of programs, feel free to follow up. What we're going to talk about today is artificial intelligence with an engineering design focus. So you may have heard the adage attributed to Thomas Edison that innovation without execution is a hallucination. And I think that's very apropos in this day and age. A lot of people have cool ideas, but taking a cool idea, an innovative idea, and turning it into a real solution to a real world problem, that's where you have real power to transform the world. And that's what I want you to be thinking about potentially as future engineers, scientists, artists, musicians, whatever field you're in, it's going to intersect with technology in interesting ways. So go ahead and take the first slide, please. And just to let you all know, so there are two things that I want to give a disclaimer. One, if you notice, we've kind of set decorated a little bit for Easter because the holidays may get disrupted a little bit, and I'm big on holidays. Two, I made sure to include some of my transformers. So if any of your parents may recognize these, this is actually a Generation 1, first generation Jetfire transformer. Everybody here is rolling their eyes at me right now. But this is actually what got me interested in technology. So what you may not know is this jet transforms into an awesome robot as well. And the idea that we could potentially have autonomous robots that are essentially sentient agent beings, just like humans, was pretty far out there when I was a kid. But we're much closer to that today than we ever were. And part of the reason that we're closer to that is the move towards artificial intelligence, machine learning, and the idea that we can train computers to simulate and mimic human intelligence. So that to me is very exciting because that's one step closer to this guy being real. So what I want to first address is, what is intelligence? When we think about intelligence, it's the ability to learn or understand, to deal with new things. So I am not a big fan of test taking. I don't believe tests are a good measure of human intelligence. So for those of you that are being exempted from some of the standardized tests, awesome, because that's not where you learn. These kind of events are the opportunities for real learning. So you don't measure intelligence by your ability to memorize facts and rote information. You measure intelligence by your ability to learn and adapt in new situations. This is an example. This digital YouthSpark, this is the first of its kind. It's going to be a little bit clunky, probably on my end, on everybody's part, because this is the first time we've done this, but we developed a solution in response to COVID and the lockdown. The mission of Microsoft is to empower every individual and organization to achieve more through technology. And our ability to turn this into a live online experience for you is entirely relying on those technologies. So we're using Microsoft Teams, we're using DSLR digital cameras, digital microphone interfaces, a lot of technology that makes all of this possible. And my hope is that some of you will be in a position to create those solutions in the future, but certainly to be able to use technology to address the problems of today. So that's also a way of me telling you, if anything goes too terribly wrong, give us a break. This is the first time we're doing this. So intelligence, the ability to learn or understand, to deal with new or trying situations, the ability to apply knowledge, to manipulate one's environment, and to think abstractly. I love abstract thinking, thinking outside of the box. It bores me to think of things in the way that other people do. Anytime I'm approaching a problem, one of the first things I do before I even research how other people are thinking about it, I formulate my own ideas. I let my creativity sort of run wild, and then I do a lot of research to figure out how do other people think about this. So the idea to think abstractly, outside the box. Now, what is artificial intelligence? This will seem semantic. I promise you, I'm not just reading you definitions for fun. These are important. There are two primary definitions. One is a branch of computer science dealing with the simulation of intelligent behavior. So the simulation, that's important. The capability of machines to imitate human intelligent behavior. That's a second definition. Next slide, please. So when we take those together, it's interesting because there are essentially two types of AI out there. What is artificial intelligence? There's a weak AI, which simulates human intelligence. This is the sort of AI that appears to be intelligent, but really it's responding to a series of pre-programmed responses, and they may be very sophisticated. This kind of AI is useful. It's much cheaper. It's very effective in a lot of settings, but to me, it's less interesting. But some of the things that identify a weak AI, it relies on algorithms and programmatic responses to simulate behavior, going back to that first definition of AI. The computer follows a program or action based on input. For instance, Alexa can recognize keywords, sounds, patterns to trigger. So if you tell Alexa, turn on the lights, Alexa's not really understanding what you want. It's just recognizing that quantized waveform of your voice that corresponds to a computer interpreted signal to turn on those lights, a computer response to turn those lights on. But it's not thinking, it's just sort of responding to what you're asking it to do. It may appear convincing and intelligent, but no actual thinking occurs. Next slide. This is the AI that I'm more interested in, and if any of you would like to, hang out at home, develop something cool, and go to college for fun because you're a millionaire sitting on a patented technology, this is where you want to focus. Strong AI systems are designed to mimic the human brain. It's very different. They're trying to recreate how our brain functions, how we perceive information, take in that information and transform it into some actionable course of decision making. I'm going very fast through this because normally I do this lecture in an hour, and I have 1 hour to do this and a design thinking lecture. So we're going to go quick, but I'm going to make all these slides available to you later. So if you miss anything, don't worry, and you can always follow up with me afterwards. Strong AIs are designed to be cognitive. That means they're aware of context and nuance, and we're going to get into this later. Remember, I'm going to do a callback to this, but there's a huge difference if I say, I feel sick today, and if I say, I'm sick of eating ramen noodles because that's all we managed to get from Sam's before everything sold out. Big difference in the context of those two phrases, right? A strong AI can start to recognize those nuances. The decisions are not strictly programmatic, but they're based on a reasoned analysis. Once we start thinking reason, that's when we're in the domain of human intelligence. Computers typically, traditionally, have not had the ability to reason. They've had the ability to compute and to use algorithmic processes to make decisions, but not to reason in the sense that humans do. So that means they're capable of making decisions, a strong AI, with incomplete information. That's huge. For any of you going out into the job world, once you graduate high school or graduate college, the most important thing an employer is going to look at is your ability to execute and make decisions with incomplete information. Because ask your parents, how often at your job do you have all of the information you possibly need to make a decision? I've never heard anybody say, yeah, I had absolutely every single piece of information I needed. It doesn't happen in the real world. You have incomplete information. That's why the COVID models change every day. They're taking in the information, they're adapting, they're making informed decisions and modeling based on incomplete information, which means it's dynamic. Dynamic means that it learns and adapts as it assimilates new information. That's also key. We don't want a computer program that can only work as an AI, as a strong AI, with the information that it was originally coded with. Instead, we want a system that can take in new information, ever-changing information, adaptive information, and make new decisions based on that. So the goals of a strong AI vary. They're all going to look different, but these are some of the core principles. Next slide, please. Machine learning is a term you've probably heard a lot. A lot of adults, I would challenge most of you, ask your parents what AI is. See if they can give you a definition. Even a lot of people that I know that work in the field of AI have difficulty explaining what exactly it is. Machine learning is one of those terms as well, or phrases that you may have heard, but you may not know what it means, and that's fine. Basically, it's a process that gives the computer access to data, to information, and allows it to learn from that information, as we described earlier, and begin to make decisions. So Alexa, as I mentioned, is not necessarily learning every time you tell it to turn on the lights. It just turns on the lights. But the Nest thermostat begins to learn from your daily routine and recognize, you know what, on weekdays you get up at 6 a.m. and you want it to be cool, so it's going to begin to adjust your thermostat. But on weekends you sleep in until 10 o'clock and you're not necessarily up and around, so it's going to respond differently. And maybe it'll begin to recognize that on Thursdays and Tuesdays you go to Brazilian Jiu-Jitsu every night, and so on those nights it's going to turn down your air conditioner to save money, or it's going to turn up the temperature to save you money because it's learning from your behaviors. That's key. That's very important, and that's all through machine learning. Next slide, please. So what I want y'all to do now, and feel free to kind of propagate some of these into the chat, I want y'all to think about weak and strong AIs that you're seeing in the real world. Alexa and Siri are examples of sort of a mix. I think both of them are integrating more strong AI processes, or at least adapting to try to do that. The Tesla self-driving car is a great example. I want a strong AI in that vehicle because I want it to learn from everything around it, to take in its environment, learn from accidents, all of these things. I really want my self-driving vehicle to have some strong AI included. Netflix is an example. So if I asked y'all, does Netflix have a strong or weak AI? What do you think? I don't know. It tries to recognize your viewing patterns and make reasoned suggestions, but it's doing that with a pretty prescriptive algorithm. I don't think it's at the point now of applying a strong AI. It's not finding something entirely out of your viewing history. It's associating keywords and phrases, genres, things like that. So that's probably a weak AI. Drones, which is another area that I work in, drones use both weak and strong AI because we want drones ultimately to shift from being sort of primarily manual, semi-autonomous to being primarily autonomous. There will always be a human in the control loop. Getting feedback. I hope it's not from me. Next slide, please. All right. So key to understanding an AI, and for any of you interested in sort of working in the field of AI, data science, there are a lot of very cool opportunities. As many people as are losing their jobs right now, there are that many jobs, if not 10 times that, opening up in the areas of sensor design and development, data aggregation, ways that we can gather information to train all of these new AI systems that are being developed. How does everything sound for y'all? Everybody hearing?
Yes,
I think everything sounds great.
Okay.
Yeah,
okay.
you sound fine.
I was hearing some feedback, so I wanted to make sure it wasn't me before I just railed on. So the two most important things to consider when training an AI are the quality of the data and the quantity of the data. If we have millions of data points, Microsoft developed an interesting AI to try to help preserve snow leopards, which is, I think, a very cool project. And one of the ways they do that is by trying to track snow leopards in the wild and figure out where they endanger, what's killing them. And one of the difficulties is no two snow leopards look alike. So when they're setting up automatic camera systems to try to identify snow leopards, it's very difficult to do using traditional methods because every snow leopard has spot patterns that are different. So what they did is they created an AI that looked at millions of data points of images of snow leopards and tigers and lions and bears and whatever else, cars, and got pretty good at telling the difference between a bear and a snow leopard. And then it got even better and could tell the difference between a snow leopard and a mountain lion. So that's pretty sophisticated, and that's very cool. But it did that through having a large amount of data. The other thing we want to make sure is that we have good quality of data. So most of you have probably had, or if not you, your parents definitely have had an issue where you want your email to filter out spam, but in that process, it filters out a lot of good information, good emails that you actually want. The reason being is that as that process, as your system is filtering out spam, occasionally it gets some good emails in there, and the more of those good emails that are in there, the more it repeats that pattern. It begins to identify other things as potential threats that really are not threats. So the data that you feed into that, if you're able to unflag those emails over time, your email system will get better at identifying spam versus an email solicitation from a restaurant that you actually signed into a mailing list and you want that solicitation, right? So the quality of the information is huge. If I fed 1 million data points as a joke into the snow leopard system and they were all pictures of my German shepherds, because I have 3 German shepherds and I like to share pictures of them, and if I just added all those to the Microsoft snow leopard database, it would mess that system up, and all of a sudden it would start identifying wolves as snow leopards because my dogs look like wolves. So the training is not one and done. It's a continuous process, and this is what we talked about earlier with learning. We want to make sure that the system is learning and adapting over time. The more information that you feed it, the better it gets. The quality increases. The quantity helps to increase the quality by providing more data points. Next slide, please. All right. So real quick, I'll open it up, and what we'll do, Amanda Hines, are you there from the retail store in the Houston Galleria?
Hi, Cesar. Yes, I'm here.
Hey. So Amanda was previously a community development specialist, and she and I worked together on a lot of education projects. And one of the things she's going to be doing this session is helping to vet. She sort of knows me and she knows the kind of answers I'm looking for. So as you're aggregating things to the chat feed, as you're responding to questions, she may pick some of those and sort of shout them out to me so I can go off of it. It's really hard for me to just do this to a camera. I like having a group of people that I can talk to and interact with and see your face and ask you questions. So this isn't really my native kind of format. So Amanda's going to help with that. We're going to transition and talking about design thinking, but right now just very quickly, is there anything that I covered that was confusing? Any questions about AI that you want me to address before we move on to talking about how we can apply design thinking to AI? Go ahead and start filling the chat with any of those questions. There are no stupid questions relating to AI. When I started actually working more regularly with AI, I had to consult friends of mine that work as developers for Microsoft, and they do this all day, every day, code for AI systems. And even they were not very certain on some of the terminology around it. We had to really talk through a lot of the finer points because it's a technology that's evolving every day. So don't feel shy about asking any questions. And Amanda, if you see any pop up, I'm going to kind of go into the design thinking and type your questions up, and I can stop at any point and she'll shout those out to me.
Yeah, Cesar, we do have one that's popped in the window. What's the difference between machine learning and AI? So if you could just kind of recap that.
Yeah, so machine learning is essentially a process that facilitates an AI. So the machine learning is the process that helps the AI function. So think of AI as a larger system. And as part of that system, like your car is a system, the engine is part of the car, your brakes are part of the car. The emergent property of the car, and emergent property is a key term. The emergent property is the thing a car does. So like a car transports you from one place to another. It moves, it drives. The emergent property of an airplane is it flies. So within that emergent system, there are a lot of subsystems that help to achieve that emergent property. So with a car, you have the wheels, you have the tires, you have the propulsion system, you have the engine, you have transmission, all of these systems. In an AI, you have sensor systems that actually help to gather the information. You have interface systems that help you to put that input that information. The machine learning is the component of that system that helps to take that data that's coming in and start to identify patterns and then change the system dynamically as it recognizes those patterns. So it's essentially a subcomponent of a larger AI system. Does that make sense? All right. Any others, Amanda?
That is it for now.
I was kind of hoping there might be some about transformers at this point, but we'll get there.
Cesar, I actually have one for you, and that is as you think about AI systems and where we are in terms of AI, there's a lot to be said in terms of what's happening in terms of the current market. How, in like a minute, could you describe how you think AI will play a role in digital transformation, and then why that makes sense for the students that are joining today's call, so that they can have an idea that AI isn't this kind of nebulous term, but it's something that's really impactful in terms of that they can get into and really be leaders at today. Because I think you've done a great job of that.
Yeah, so that's a really good question, and I think it's super relevant. And here's why. To me, the largest value of AI, I don't think we should ever have machines replace human intelligence, because then we end up with the Terminator, and luckily there's been a recent enough movie that y'all sort of know how that turned out, right? So we don't want to go down that path. But I think that there are a lot of ways that AI systems can supplement human intelligence, and combined, humans and computers can achieve more. And so one of the areas that I think AI is going to be the most impactful, and you're seeing this right now, at home, you're being bombarded by just a swarm of information, right? The day schools got canceled, 1,000,001 online learning platforms launched and started advertising and sending advertisements to your parents' Facebook feeds and LinkedIn and Twitter and Instagram, probably even something on TikTok, unfortunately. And so as those technologies proliferate, or those platforms proliferate, it's very hard to figure out, to sort all of that data. For a human being to go through every one of those and figure out which one's right for me is very difficult. Where AI is very helpful is looking at huge amounts of data, recognizing patterns, and then giving humans the information that's relevant to your current situation. So that is where I think helping us to deal with this huge abundance of data that we're going to be taking in right now. If you go to YouTube, there's a million, or not a million, there's millions and millions of videos on YouTube. Years ago, when YouTube first came out, there were a handful of videos. If the first few days of YouTube, there were a few hundred videos. You could literally go down a playlist and watch every video on YouTube. That's no longer possible. And society will never exist in that way again. And because of the shift to online data and the online transformation we're going through now, it's going to be more and more important to have computer systems that help us deal with this overflow of information and figure out what's relevant to us. And that's a huge opportunity for you. As students, previously they said over 65% of the jobs that you will fill as students don't exist currently, which is pretty cool, because that means you're going to go out there and have the opportunity to create your own path in life and create jobs that don't even exist. My guess, and to Romel's point, because of this current situation, I'm betting that number has gone up from 65. I'm just going to throw something out there and speculate that it's going to go up to 85 to 90%. I think the vast majority of next generation jobs that you will all be filling when you get out of college and high school don't exist today, or certainly don't exist. They don't look the same today as they will look 5 years from now. Is that an answer to your question, Ramel?
That's perfect. Thanks, Cesar.
Okay. And that's a perfect segue into design thinking. So I don't know in schools, well, I'm going to throw something else controversial out there to you. I think that, so for me, I didn't enjoy school when I was in middle school, high school. I hated school. I intentionally got thrown into detention every week, because if I went to detention, they gave me all of my assignments and they let me do them at my own pace, and then I could do whatever else I wanted. And so I would read, and I would play role-playing games, and look at Transformers comics, and just whatever I wanted to do. A lot of you are going to find yourself in that self-paced system working from home right now, unless you're Romel's kids and have to get up early in the morning and put on your uniform still. The rest of you, you're going to find yourself in a very self-paced system, my sense is, and it's going to open the opportunity for you to do project-based learning and learn from real-world application of skills. And to me, that's so much better than just reading a textbook without doing something fun. So my guess is a lot of you may be a little familiar with design thinking, but you probably never applied it in a group, in a team setting to complete a complex project. So I want to go through, I looked at a lot of models online, and I actually don't like very many of them. I think some of them get it wrong, but the basics are pretty consistent. So what we do in the engineering design process is we begin by defining and identifying a problem. Because once again, my belief is, as an engineer, if you're not solving a real problem for somebody's life or meeting a need, then you've failed. It doesn't matter how cool the thing you've invented is. I think the Segway might be an example of that. You start with a problem, then we identify the constraints. We figure out, is this viable? Can we create this? The movie Avatar. The idea for the movie Avatar came out 10 years before the movie, but the computer technology, the rendering technology for 3D animation didn't exist until 10 years later, and then it became the highest grossing movie of all time. So the idea came out before it was a viable product, technology. Then we move to brainstorming. We start thinking of multiple solutions. We select the most promising solution. We prototype that solution. We test that prototype. We iterate to improve the prototype. Here's where it kind of breaks down for me. I don't like that they put communication at the end. And that's I think, an artifact of an old business model where you would create a product, your customer would come to you, give you a need, you would create a product, you go through all of this process, then you present the product back to your customer and explain why this works. The world doesn't really work like that anymore. Customers are much more hands-on. Microsoft enterprise clients, the clients that work with them on these large solutions, are very hands-on with what their needs are. So what actually happens more so now is at every stage of this process, when you identify your problem, the first thing you have to do is communicate that problem to your stakeholders. You're going to have to go to somebody, a venture capitalist or your boss or whoever, and say, hey, I got a brilliant idea, but I need money, or I need I need you to set my next quarter work schedule to work on this. Then when you identify all of the brainstorming, you're working with a team. If you're not able to communicate effectively on a team, you will never execute a higher level project, ever. Moving down at every stage of this, when you develop your prototype, you're going to be having to, once again, communicate with diverse teams, chemical engineers, mechanical engineers, computer scientists, business people, marketing people. All of those different people, you're going to have to communicate. You test the idea, you iterate, once again. So I would sort of put that communication cog at the center of the engineering design process and reimagine this diagram. But all of those steps are pretty standard. Next slide, please. So one of the first things that we need to do when we're coming up with any product idea is create a value proposition. We identify a problem or need, and then we figure out, is anybody going to buy this? Just because this would be cool to me doesn't mean it would be cool to everybody. And just because something's a problem for me doesn't mean everybody has that problem. So here's an example. How many of you make your beds, or your parents expect you to make your beds every morning? Probably a lot of you, right? So I've got a better solution. I could have a NASCAR crew rush into your room every day. They can make your bed in 3.2 seconds, dust your shelves, and be out before you even know what happened. Is that a cool solution? To you, maybe, but it would cost your parents $8,000 per morning. So my guess is that all the parents in the rooms hearing this right now are shaking their heads no, because they've got a better pre-existing solution, and that's you. They gave birth to you. They room and board you. You can make your bed every morning. It may take you longer than a NASCAR crew, but it's an existing solution that's already better. So there's really no market need for that. So there's no value proposition. So we need to identify the problem, make sure there's a market, make sure we can make a value proposition to that market. Why does this matter to you? Why should you invest in this? And then typically you have to pitch that to somebody, which you've seen Shark Tank. And that's a great example. A good friend of mine, Henner Gracie, delivered a Shark Tank presentation on the Quick Flip hoodie. He created a new hoodie that turns into a backpack, and he delivered a Shark Tank presentation on that idea. And that's an amazing example of something that, you all have hoodies, you all have clothes. What was the value proposition in a new one? He was able to articulate that value proposition in a way that convinced the sharks to invest. And that's a really good example of the kinds of opportunities you may have. Next slide, please. All right. So brainstorming and identifying problems. We're going to do a little bit of that right here. I'm going to go through a few that I identified that are, I think, on everybody's mind right now with COVID. And then I want you to start adding some to the feed. We're going to do a little exercise. And then hopefully you'll continue this after today with your parents, brothers, sisters, friends online, teachers. So next slide, please. I'm going to go to a few that I identified. Survival resources, food, medicine, toilet paper, the things that apparently you can't live without in an apocalypse, right? Connectivity for business, entertainment in isolation. Hopefully this somewhat qualifies. Online learning, again, hopefully this somewhat qualifies. Current accurate information. How many of you are seeing different reports on TV about whether you can come and go, whether you can go to the store, whether there's lockdown, whether you should wear a mask or not wear a mask? Laws and restrictions. I just saw a news report about surfers getting fined or ticketed or reprimanded in California because they're out surfing in the ocean, separated by a barrier of viscous fluid with a salt content that kills viruses. Nonetheless, they weren't aware of that law and restriction, and police made them aware of that. So research and prevention. Here's one that's really interesting to me. So I'm going to go ahead and ideate a solution, and I'm going to walk you through the process that I would use to apply the engineering design process. So when I think of research and prevention, one of the things that occurs to me is that everybody is using social media right now, right? So what if we had an AI that was capable of looking at all of the data from your different social media feeds, applying machine learning, and starting to recognize trends and patterns, and recognizing that the difference, as I mentioned earlier, I said I was going to do a callback to this, the difference between you saying, I'm feeling sick right now, or I'm sick of eating ramen noodles every day, right? It's an important distinction. But what if this AI started to gather that information and then created maps to help identify nodes of outbreaks? So you could see, okay, there are increased social media phrases and cues and references to disease in this particular city. Even though we're not seeing people in the hospital yet, we can start to send resources there, because based on this information, the AI has determined that there's likely to be an outbreak in this area. I think that would be a really cool solution. There are some problems with that, though. With the traditional, if I use a weak AI, I'm just gathering information based on last week's, or last month's pre-COVID situation. Next slide, please. So I went through some of this. The AI would be a crowd and cloud source social media data to identify patterns in the spread and origination of COVID outbreaks. We would use AI data mining to identify posts that indicate illness by recognizing keywords. A weak AI might be able to tell the difference between I feel sick and I feel sick of eating ramen noodles, but it's using an algorithmic pattern to detect that, right? A strong AI would adapt dynamically to new uses of language. And I think there's a really important one out there that a lot of you are familiar with. Next slide, please. Now, if I'm trying to figure out who is responsible for spreading COVID, I need to be aware of dynamic changes in the use of language. And so if somebody were to tweet or post an Instagram meme that said, Carol Baskin's spreading coronavirus to tigers, a month ago, I might say, well, we need to get the FBI, figure out where this Carol Baskin is. Maybe we still do. I'm not going to rule that out. But the language has changed. Now it's pretty understandable that that's a joke. That's a common cultural vernacular. It's a joke going around because of the popular Netflix series. So nobody is going to show up on Carol Baskin's door and say, hey, we saw online a lot of people are suggesting that you spread coronavirus to the tiger that got sick in the zoo. People understand that that's a joke. A strong AI would begin to recognize the patterns in language uses and how they change, and actually update its registry to accommodate those changes in language. And that way we're not wasting, I make this, but it's actually really important that we not waste government resources tracking down leads that are maybe comical or a joke or not authentic. We need to spend those government resources tracking down actual leads. And so we don't want an AI that's going to be tricked by changing cultural use of language. All right, next slide, please. All right. So what I want y'all to do right now is to focus on, Shalí likes my social distancing world champion. It's true though, right? How many of y'all have seen him? What I want y'all to do right now is focus on some problems that you might use AI to address. Draw from your own experience. I want you to identify a prospective target market. Apply the engineering design process very quickly in your heads. Does a good solution already exist? Go back to that NASCAR analogy. Type your ideas into the chat window. Try to use single words or short phrases to make it easier. Amanda's going to sort of go through those and pick a few of the top ones, and then we're going to do an exercise where we work through those. So go ahead and start typing those. Ramel, how are we doing on time?
Hey, Cesar, great question. We have about 5 minutes, so we're going to go into our next session, our transition at 11:07. So we have about 5 minutes.
Okay. Are we going to do which session are we going into next?
Our next session will, we're going to actually go into our music productions, actually IP. Our intellectual property session will be the next session, but we're going to take a small break, and
Okay.
I'm going to introduce our special MC as well, which will be Lady Jade in just a few moments.
Okay, perfect. So Amanda, have any ideas? And like I said, I want y'all to first focus on just identify a problem. Maybe your problem is that now you're stuck in the room with your little brother and you just wish there was an AI solution to make him not be in the same location as you. I don't know if we could find one, but that might be a problem. Identify some problems that you're facing at home, or maybe that you see your parents or other people facing, and we'll spend about 5 minutes talking through one of those. I just want to show you how the mental process of identifying the problem and moving towards a solution, how that works. All right, so Amanda, what do we see?
I'm waiting for some ideas to come through. So if anybody has any that they'd like to talk about or share, making online learning more efficient and interesting was just shared by David.
Okay, so let's take that one. I think that's going to be, my guess is that a lot of you, we don't know what's going to happen, but my guess is that a lot of you may not be going back to traditional school. I'm not saying schools won't reopen, but I think that when they do, so many of those schools have adapted to the online learning ecosystem that what you experience at school could be really different than what you were used to. Now we need to figure out how can we apply new technologies to enhance that and make it better. And I think that one of the ways that we could potentially apply AI is to start to look at learning outcomes. So when you participate in a session like this, normally what I would do is after this, I would have you do a design challenge where you work with a group to identify a problem, formulate a solution, develop a Shark Tank style pitch, deliver that pitch to a panel of experts, and you would compete with each other. To me, I found that that's a very effective way to get you thinking. There are a lot of other people that are coming up with some really interesting and effective tools online, but my guess is there are probably a lot of tools, maybe you've experienced these, that are just clunky and not very good and not very fun, not useful. So I think having some sort of an AI that could track things like user engagement, how users transition from that particular learning experience, like Khan Academy would be a great one. How do people transition from Khan Academy to other formats like Microsoft Learn, Coursera, and tracking those metrics, applying an AI to recognize patterns for effective pedagogy, which is the practice of sort of how do we, the theoretical approach to applying learning and education. And I think we could develop a very cool AI, and if any of you have ideas to do this, look into it, to start to gather all the data that's being produced about the different types of learning environments and create an AI to determine which of those are generating strong learning outcomes and leading to next level learning experiences. I think that would be a very cool one, and that's the way I approach starting with the problem and applying engineering design process. Any others, Amanda? And then we can
yeah, I just wanted to call out, Jose has just added an additional comment to the learning, the online learning piece is one that makes a regression of when to host online classes based on the teacher and student schedule to kind of designate when those classes would be hosted most effectively for student and teacher scheduling. And the last, I'll go ahead and just read it out to you to let you know. I think an AI solution could be helpful to identify less crowded grocery stores to prevent overcrowding and minimizing the possibility of virus spread.
Yes, so I love both of those. And the first one, the idea of looking at sort of traffic streams, optimal times of day to host classes, that kind of a scheduling app, I think that would be an amazing feature to add to the first AI we sort of outlined for looking at responsive learning patterns. they've done things like this for marketing to help marketers figure out when are people most likely to be on Facebook and see an advertisement. They have entire algorithms that are basically help to determine when is the optimal time for you to release an advertisement on a particular product that your target market would see that. So I think what you've described would be a perfect layer to what we already talked about. And the core technology to do that already exists because they're applying it to advertising. So if we could migrate that technology that's used for marketing and advertising and turn it into something that could be used to track optimal schedules for students, I would be very interested in knowing what time of day do you learn the best. I don't learn really well early in the morning. I want to get up, play with my dogs, have some coffee, chill out for a while. If you force me to learn something in the morning, I'm probably not going to retain as much of it as I might in the afternoon. So I think that's a brilliant suggestion. And Amanda, remind the second one.
Yes, an AI solution could be helpful to identify less crowded grocery stores to prevent overcrowding and minimizing the possibility of virus spread.
Yes, so I also love that one because I think you can apply an Internet of Things approach, which is how can you make inherently non-interactive or traditionally non-interactive objects and aspects of our life, transform those into interactive agents by adding sensors, by making them capable of gathering and transmitting data. So a great example of that may have sounded too technical, but it's not. Waze, the Waze app for cell phones, it's basically a driving app that uses crowdsourced data from drivers to determine traffic patterns. And I found it to be far more effective than Google Maps or any of the map apps because it's being crowdsourced dynamically by people that are driving. And so what it's doing is previously drivers were not connected to the internet, right? We don't want drivers on texting about the traffic patterns where they are, but Waze actually tracks the flow of those drivers through the app without them having to do anything and starts to identify traffic patterns. I think it would be amazing to convert that technology and adapt something that would also track patterns in stores and help you determine which grocery stores are crowded. And even like Waze allows you to tag, if you see a cop, you can tag it, or if you see debris in the road, you can tag it. What if you could also tag grocery stores based on this one has toilet paper, or this one has, beef ribs, which is an important staple of my apocalyptic diet. And if we could start to allow users to tag those things and allow the app to sort of track people's behaviors, I think that could be very interesting. The issue that we will run into with that, and you've probably heard about this in the news, is the privacy constraints. Do we necessarily want an app or the government tracking our location? There's some interesting invasion of privacy questions. So for those of you that are interested in law and technology, being in the space of being the person who helps, the lawyer that helps determine what are the laws that regulate that kind of an app, you can have as amazing as a career as you would have being the person that developed the app.